Hello, so in this video we'll be looking at the question number 283, move zeros from Leetcode. This is a pretty interesting question. I came up with two solutions for this problem, and those solutions had a very significant difference between each other, and I thought it was very important to talk about. So first let's read the question. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So let's take an example. We're given a integer list nums. So as you can see, there are zero values in the middle of the list. Our job is to take these zero elements and move them to the end of the list, giving an outcome somewhat similar to this. As you can see, the zero elements have been moved to the back. So as I said, I had come up with two solutions for this question. So let's look at the first solution first. So for I in nums, so we'll be using a for each loop for this. If I is equal to 0, if I is equal to 0, then nums dot remove 0, nums dot remove I, and then nums dot append I. So what we've done here is we use a for each loop to loop to each elements in the nums list, and then whenever we come across a 0 element, we remove it from the list and then append the 0 again inside the list to, so like we remove it from the current index and then append the 0 into the final index of the into the end of the list. So if we run this code, it's accepted. Let's submit it. So as you can see, the code is accepted. However, the runtime is actually 1773 ms, which is almost equal to 2 seconds. So as you can see, it is a very slow algorithm if we think about it. So now let's move. So talking about that, we'll look at the second solution. So for the second solution, we initiate an empty list in the beginning. After that, we again use a for each loop for I in nums. So for I in nums. So now we check. Now our duty, this L2 list is supposed to contain all the non-zero elements in the nums list. So what we do is, if I is not equal to 0, then we insert the element into the L2 list. So L2 dot append I. So now we know that the L2 list contains all the non-zero elements inside the nums list. So after we have done that, we use another for loop. So this is the for each loop, but this time we'll use a for loop for I in range 0 comma length of nums. So we run till the end and the final index of the nums list. So again, now we have a condition, that is, if the length of L2 is greater than I. So what this validates is that it validates that there are still elements in the L2 list that we have not worked with. So in that case, what we'll do is we'll set the value of the I index in the nums list. So the nums I is equal to L2I. So what we've done here is, if there are elements inside the L2 list uh, that we have not worked with, then we just simply take that element and then keep it into the I index of the nums list. So what this results is in that until there are elements in the L2 list, we put the values of those index into the same index inside the nums list, and then else That is, once we have replaced the index values of every single elements in the L2 list inside into the nums list, the remaining values are just zeros. So what we'll now do is we just replace the remaining values in the nums list with zeros. So nums I is equal to 0. So this is all of the algorithm. Let's run this solution. Okay, so sorry, if I is not equal to 0. As you can see, it has been accepted, and let's submit the code now. So as you can see, there is actually a really huge difference between the runtimes. This was a success too. So as you can see, the second solution, this solution where we use the two for loops, has a runtime of 287 milliseconds, and the previous solution where we use the where the code was pretty short, as we can see over here, even though the lines of codes were very less compared to the second solution, it has a very high runtime. So I'm not exactly sure why this is happening, but as I think, the main reason is the nums dot remove function that we have used here. So as I researched the big O of list dot remove in Python, so as you can see, it is said that the big O notation of the nums dot remove is set to be on, and it is not the best function to use to remove any elements from a list. So replacing the nums dot remove function with the from in this solution just decreases the runtime in a very significant amount. So that is all for this video.